Hi class, let's take a look at problem 10. Now in problem 10, they're asking us to, take a look at some of these exponents in order to justify this formula that showed up in this section. So let me just carry out the evaluation so that we can see the pattern. Now if you evaluate 3 to the 4, this is going to be equal to 81. 3 to the third, it's going to be 27. 3 to the second is 9. And 3 to the first is technically 3. And technically, using the property 3 to the 0 is 1. But observe what happens here with the following pattern. And this has to do as you reduce the actual powers. So for example, if you evaluate 81 and then you divide it by 3, you're going to actually obtain 27. If you divide it by 3 again, you're going to obtain 9. If you divide it by 3 again, you're going to obtain 3. And if you divide 3 by 3 again, you're going to obtain 1. So it's part of the pattern. In this pattern that you see here, it's basically this graph. So these exponentials represent graphs of the following form. So at this point, this is y is equal to 3 to the x. And then to justify the formula, or for us to get a better understanding of the formula, it suffices to see the pattern here that 3 to the 0 is equal to 1. It's basically the result of a division of powers of 3's. And then also a graphical picture is this coordinate point here. As you can see, this is your 0, 1, or the value of 3 to the 0, which is equal to 1. So this is a graph, and this is the graph of the equation y is equal to 3 to the x. Another way to justify it is add the x is equal to 0. In this case, add 0 here. You're at the coordinate point of 1. So this exercise was just to justify the formula. So technically, you can see it as a result of divisions of 3, and then also as part of the graph. That's actually it for this one. We've been using this x to the 0 equal to 1 in several problems, and this example here is just to solidify that knowledge. Okay, let's move on to 11. Okay, and on problem 11, they want us to check if the expansion is correct, and in this case, it is not. And let me just explain why. If you have x plus 2 squared, this represents x plus 2 times the values of x plus 2. So in order to raise x plus 2 to the second, you have to multiply it twice. And in this case, we end up evaluating by the FOIL method, which means that x and x is equal to x to the second. X and 2 would be the values of 2x. 2 and x is going to be another 2x, and 2 times 2 would be 4. So in this case, you're going to end up with x to the second plus 4x plus 4. So in this case, let me just rewrite it in a sentence. And I'll just say, no, the expansion is not correct. And this is because x squared, actually, let me rewrite it as it's stated. X plus 2 squared is equal to x squared plus 4x plus 4, which is not equal to x squared plus 4. I'm just expressing in a sentence that no, this is a common error. When we expand a binomial, the FOIL method takes place. And in the FOIL method, some of these combine. For this specific problem, they combine to 4x. That's actually it for problem 11. It's one of those problems that we wanted to clarify because these multiplications will show up in later modules as well.